Hello there. Today we are going to start Unit 4 in Software Engineering. Uh, this in this video we are going to see. Let me make it my pen. Okay. Unit 4 Introduction to UML. In today's class or video, we are going to see importance of modeling and principle of modeling. We are going to cover these points in our video today. So, what is an object-oriented modeling? Object-oriented modeling or software development method from structural programming to object-oriented was started from 17 to 18. It went on from 17 to 80. That is, we got structural programming. From 80s, we got object-oriented programming. So there were two evolution passes. In 70s, we have structural programming, and 90s, we have got object-oriented. And what is structural programming? Structural design with object-oriented design process. And we have got structural analysis. We have got object-oriented analysis. These were the difference here in this one. Object-oriented modeling started way back, started in 90s. Before that one, it was standard structure programming. So if you go for the differences of structure programming and object-oriented programming, focus on clarity and what is quality, how to develop a computer program. Concept of object came into existence. Use of structures and loops came in structure programming, whereas it came of encapsulation behavior promoting modularity. Reduce the complexity. Here was the key mode of reducing complexity. Include encapsulation, inheritance, and polymorphisms was the concept here. Structure design, planning software that emphasize dividing the program into modules. Focus on designing a system. Collaboration of interactive system. Modularity, maintainability was the major concern here. Use of UML, Unified Modeling Language, created diagram, class diagram, six-phase diagram were emphasized. Often use data flow diagram, DFDs, whereas emphasize on relationship, how interactions goes up. Focus of understanding, documentation, requirement, involving analyzing system requirements and other things. Use of technology of DFDs, data flow diagram, entity relationship. Use technologies like use case analysis, class CRC, class responsibility, collaboration, others. Aim to gap between the system requirement of software design. The major part, object oriented, was to bring back or reduce the gap between software requirement or software design. It was there in 70s and 80s. Structure programming, this was there 80s to 90s. Correct? Now let's move on to the slide. Why UML is important. Use graphical notation, very important to communicate more clarity than natural language. Help to acquire overall view of the system. Tools that can use generate code that can be used for various languages with help of UML. UML does not it's not dependent on any language or technologies. Its picture speaks 1,000 words, which is a very important part when we do it. UML can be defined simple modeling mechanism to model all possible practice diagrams. This was the history of UML. Other methods were used, and Botch came in 1991, OMT in 1990, OS was there, and then we move on to Botch 93, OMT2, and then other method, we call them as Unified Method 0.08. Then OS came into existence with that one, that is UML 0.9 and 9.1. Then UML 1. So we have got fragmentation, then unification, then standardization, then standards based on public feedback. So fragmentation, other parts are available here. Unification, when all came into existence. Then here all, this part and this part came for a standardization process. Then industrial use based on feedback. It got improved on feedback. Feedback was used to improve. to improve. The same is given in the next slide. Fragmentation. Initially, fragmentation was multiplied. Competing methods and notation were used in modeling space. This is called fragmentation. Initially, there were number of steps available, number of methods were used. Then unification, a collaboration between Bosch, Rombach, Jacob Marketing were developed on this one. Market unification of this method into single cohesive approach. Then standardization came. Unification approach gained tracking standardization approach. Then it is used for industrialization. Major takeaway feedback, collaborative effect within Bosch, OMT and OS. A standardizing process. Major takeaway, as I told you, feedback was a major task, and then centralizing all collaboration making into standardization. This was the part of this one. Importance of UML. What is the importance of UML? Unified modeling language is general purpose modeling language. The main aim of UML is to define the way of visualizing the way of system behave, how you visualize the system. They're quite similar to blueprint of other plate. It uses for visualization. Software organization UML diagram to behavior of the structure. Behavior means dynamicity of the software. We will see this later part. UML help to software engineer, businessman, and other model system and design process. This with the major takeaway is visualization of the system. Then impact of modeling, complex application need collaboration, planning, multiple team and required clear multiple team, because when multiple teams are working together, they need to get togetherness, or they need to cooperate with other, to communicate with other among them. Business do not understand code, businessman do not understand, so UML is used to communicate with them for program extension. Lot of time save when you draw a diagram, then a program. Then visualization process, user interaction and static structure of that is been defined. Importance of modeling, detailed documentation. Whatever the documentation is there, we have to reproduce, and historical record is the representation. Based on that documentation, we analyze. Flexibility of actual model becomes. Then we validate the requirement. Validation and verification of the requirement is done. Once it's done, blueprint of your model is ready. Development, error deduction is come down. Once your blueprint is ready, we can able to reduce the error. Once blueprint is ready, we can able to do a risk management, potential risk. Reusable. With the blueprint, we can able to see which are the reusable component and what are the pattern you can use. We can able to standardize this one, and we can use the stakeholder participation, and based on that stakeholder participate, we can also get feedback. Once we get feedback, we can able to develop our model very good. So what are the things we can able to use in UML? For an example, in requirement, we can able to use cases. In system structure, we can able to use class diagram, component diagram. In system behavior, I can use sequence diagram, activity diagram, state manner. The decision of which model to create significant impact, how the problem approach. So, how we are going to read. Wrong model will mislead to you, causing so much of irrelevant decision. And for the every model may express its different level of, every model has different way to express. If you are building a high rise something 30,000 feet, visualization is very important for us. Multiple no single model can able to. For example, if you have got electric plant is totally different from drain plan. Drain plan is different from other views. So there are different views you can able to go through. How you are going for electricity, how you are going for other. This is an example. Multiple model are needed. Connect to reality. Model reflecting reality. The best model, those simply who can able to give accurate result, accurate feature can able to use for our UML. Thank you very much. I wound up this unit, this topic.